Hello fellow problem solvers, today we're going to be doing a problem from the European Girls Math Olympiad 2013, problem number 1. This is a cool geometry problem which I suggest you try out for a minimum of 20 minutes, ideally 45 to an hour, but not more than 2 hours. If on the other hand you'd like to go along with us, I suggest you take at least 15 minutes, draw the diagram and put your first ideas out on paper. So now, let's begin. So the first thing I want to show you while I'm drawing the diagram is how I'm drawing it. I'm first drawing B, C, and D because this is the condition. You extend BC over C. I'm not even drawing A yet. And then I draw A because it says AE is 2 times CA. So I draw points A and E somewhere here such that this is 1 and this is twice that. And the last condition is AD is equal to BE. So we have points A and B such that this is supposed to be, if this is x, this is 2x, and we need to prove that if BE is equal to AD, then ABC is a right triangle. Now note, nowhere did I need to connect A and B. Really, like nowhere until the very end. So now with this picture, like thinking about the way we drew it, I'm asking you, like, do you have any ideas? Like, look at this picture. What do you see? Pause for the next, 5 minutes if you haven't drawn this picture like this. And for me, just like from the construction, what I'm getting is, look, if I, like, there's many ways to look at this. I'll first, like, do the non-big idea thing, which is, okay, we need this, like, let's solve the problem backwards. We need this to be 90. So if we take the midpoint here, of BC, then that will mean that this is equal to this, and this is going to be twice, like 2 times this is going to be equal to this. So does that remind you of anything? Maybe not. So maybe if you take the midpoint here and here, maybe we have a lot of midlines that we can work with. Now we have a midline. What is this? This is the midline. Okay, of a quadrilateral, so we don't really have much. But this is parallel to this now. So it's enough to prove that this thing right here is 90, where this is x, and this is the midpoint here. So maybe that's an interesting thing to prove. However, it's also possible that this being y, and this being 2y, and you needing to prove that this here is also y, maybe this still does not remind you of anything. To me, it's shouting out. But here's actually one way of looking at this is to try to take advantage, connect the fact that these two lines are identical. Is there maybe, can I translate 8 here? Like, can I do a point here, A prime, such that now this is a parallelogram, and now I have this is 2y as well. And now there are a bunch of angles that are equal. So now maybe this is something that's cool. And also, A is not just meant to be, but A is the midpoint of EA is equal to AA prime. And now with that, this actually solves the problem, because BA prime is then BE, then this is 90 because this is the midpoint. And that's one way of solving it. Okay, accidentally I just solved the problem. But the other way that I wanted to show you why I picked this problem was because if you construct these points, mind you, B, C, and then D. And now when you're constructing the points A and E, you're making A here and E here such that this is 2x and this is x. What is a unique point such that now if you look at this as a triangle BED, C is the midpoint, A is a point on the median such that EA is twice AC, twice as large as AC. So this is the centroid then. And now that you see this immediately solves the problem, because that means DA and the midpoint of BE are collinear. And now at that point BM, and now you have this is equal to this is equal to this, call this y, and actually we don't have it equal to this yet. This is y, and this is 2y. And because this is the centroid, this thing right here is y, twice as small as this. And now you have y, which gives you an angle of 90, and that solves the problem. It's just, the reason I wanted to show you this problem is because of the uniqueness of A. Like if you think about this at a triangle, like what defines a centroid? The thing that defines a centroid is, it's on a midline, and it divides it in this fashion of x, 2x. That is what the centroid is defined by. That is enough to define it. In geometry, sometimes points are hidden by defining them in a different way, by defining them in a way that's enough, but it doesn't give you all the information you usually have with them. So that was just a cool problem I wanted to show you, and as always, thanks for problem solving.